Dear students, welcome back to chemical technology. Last time we have seen the chloralkali industry. So this time we will see the potassium industry. So here is the history for potassium industry. The word potash comes from the fact that extraction of wood ashes with water produces the potassium hydroxide and potassium carbonate. So the potash word, the earlier we have seen the caustic word for the NaOH, and here the potash word came from the wood ashes. So ash and the potash. So wood ash, it will represent the potash. Then plant selectively removes potassium from soil and acting as a potash concentrated and denuding the soil of potassium, which must be replaced. So the plants, they will extract the potassium majorly from the soil and it will use for their growth. So potassium with nitrogen, phosphorus against the macronutrient for the plant production. Then earlier the hydroxide of the sodium and potassium was called as Li together. So this was, they were not able to separate this one. So togetherly it was called as the Li. So many of the process flow diagrams, you have seen the word Li together. That means it will have the sodium and potassium together. So potassium salts are preferred over sodium salts for laboratory and pyrotechnic works because they are less hygroscopic and they form fewer and simpler hydrates which are more stable to heat. So in general laboratory, you can see instead of the NaCl salt, most of the time we are using the potassium salts because they are less hygroscopic, means they will absorb water at less quantity, or they will absorb moisture at less quantity. Also they form the fewer and simpler hydrates which are more stable to it, whereas the NaOH hydrates, they are not stable to it and they tends to lose the water when heating. So here is the metallic potassium. It was first prepared by the H. Davy in 1807 by electrolysis of fused KOH. So similar process will adopt for the production of the potassium hydroxide. So earlier we have used the electrolysis for the sodium. So this time in chloralkali industry. So here the potassium hydroxide is obtained in the same type by electrolysis of fused potassium hydroxide. It's similar to sodium but more reactive. So earlier the sodium and potassium, if you compare, then potassium is highly reactive. It is not widely used because of this reactivity, and the commercially not prepared as potassium as it attacks electrodes and tends to remain dispersed in fused salt, and it is therefore prepared by KCl by double decomposition method with sodium. So here if you try to prepare the potassium hydroxide by the same electrolysis of NaH process, the same process we use over here, as the potassium is highly reactive than the sodium hydroxide, so it will attack the electrodes, and so generally it tends to remain in dispersed fused salts. So the electrolysis process becomes the non-commercial for the potassium production. Hence it is prepared by the KCl by double decomposition method with sodium. So the reaction will follow that sodium we are reacting with potassium chloride, then it will replace the potassium and chloride and it will form the potassium elemental form and the forming the sodium chloride. It is used in the high temperature heat transfer alloy, the potassium and sodium, and for the manufacture of the CO2, the dioxide used in life support system. Also it must be stored under unreactive gas such as nitrogen. As we have seen, it was very highly reactive. So it is kept with some unreactive gas which generally it's a nitrogen. The raw material, if you see for the potassium and potassium salt production, then the largest domestic production of potassium salt has came from deep Permian sedimentary deposits of sylvinite, that is an axial mixture of sylvite, that is KCl, and halides, NaCl, and the langbeinite, that is potassium sulfate and the magnesium sulfate mixture. The sylvinite is mined and treated to yield high grade potassium chloride, and the langbeinite processed to make potassium sulfate. So here you can see the sylvinite, it is generally used to get the potassium chloride as a salt of potassium. Then another domestic source of potassium salt is Sells Lake at Trona, which is in California, USA, which is deposit of sodium salt permitted by saturated complex brine. So here generally the natural resources, they will present these salts of potassium and that we are trying to get from it. So generally we are using the sylvinite and the brine from the Sells Lake in Trona that will use. So this process will be referred as Trona process. So the brine which is consist of salt mixture, so this brine is processed to separate high grade potassium chloride and borax together to numerous other saline products. The Israel and Jordan are building plants on the Dead Sea which are expected to have large capacities. So you have seen the Dead Sea. So Dead Sea will have the high concentration of the salts. That's why the no living organism can survive in this sea. And that's why it is called as Dead Sea. So it will have the more salt concentration, and that can be used to get these salts of potassium and other useful elements. Then Brazil and China also producers of increasing quantities, and sea will have little amounts of potassium being more reactive to soil and plants. So it is the thing that the potassium salts are less found in sea water, because the potassium has more reactivity towards soils and plants than the water. So first salt we will see is the potassium chloride. So it is mainly produced for the fertilizers, and we have seen already the sodium, the nitrogen, the phosphorus industry. So with that the potassium also is useful in the fertilizer. So in the fertilizer trade it is referred to as the muriate of potash, and chemical grade or 99.99% KCl is the basis of the manufacture of most potassium salts. So here are the three processes that we will see today for the manufacture of potassium chloride. The first being the Trona, which is taking the brine from the Salt Lake, and that is separated depend upon the solubility. And then second we will see the manufacture from sylvanite, and the third we will see the potash from Saskatchewan, Canada. So in Trona, it is from the Salt Lake, California. The shipping of potash began in 1916. The lake is composed of 4 layers. The upper layer, the composed of crystalline salt, is from 20 to 30 meter deep. Second layer, it is 4 to 5 meter of mud. The third layer, 8 meter of salts, and the bottom layer, mud interspersed with minor salt domes. So here we can see the upper layer and the bottom layer, they will consist of the salts, and we have to use the process to separate these salts from these layers. So in processing, the brine is pumped from the interstice in the salt body from the first and third layer. So you can see the various salts, then we can see the percentage in upper deposit and percentage in lower deposit. So as I have discussed, the upper layer and the bottom layer and the third layer, it will have the salt content, so that we have to separate it. So generally the upper layer will have the high concentration of salts, whereas lower deposit it will have the salt concentration but in less quantity. So if we see the salt content, so generally it will have the potassium chloride, then sodium chloride, then sulfates, then carbonates, then borax, and the sodium phosphates, and then little quantity of the sodium bromide. So this will be in quantity, that upper deposit will have the high quantity and the lower deposit will have the less quantity. So these salts, they will differ in the solubility, and depend on the solubility we will crystallize them and we can separate them in later stage. So here if we see, in the first layer of brine of the Salt Lake, the main system is the potassium, the sodium, then the sulfate, then carbonate, then borax, then chlorides, fluorides, and the quantity of water will be present. Then fractional crystallization can be done to separate salts as they differ in solubility. So as we have discussed earlier, the solubility will be differed. So if we try to concentrate the solution, or we try to change the temperature of the solution, the solubility will be affected. So the salt which is more soluble will remain in liquor, whereas the salt which is less soluble in the solvent, it will come as it will be precipitated, and that can be separated out. So depend on the solubility, we can have the temperature which affect the solubility at most. So temperature we will use to carry out the precipitation of the salts, and then we can separate them on settling. The chemists and engineers at Trona developed the method of production, and they studied phase rule to commercialize brine. The other than common salt, other have more economic value. So here you can see the NaCl will also present over there, and that becomes the major problem in this one, because the NaCl separation is not easy in this case. But other than NaCl, other salts have the economic value, and that's why we try to separate other salts from NaCl to get the more purer form and to have the high economic value for those salts. So the process involves the concentration of the potassium chloride and borax in hot brine and the simultaneous separation of salt and burkite. A new mineral with composition that carbonate and sulfate, it will be present over there. Then by virtue of the delayed crystallization of borax, the potassium chloride can be obtained by rapid cooling of concentrated brine in vacuum coolers and crystallizer. So here you can see the separation of borax from the KCl. So here we are using the delayed crystallization of the borax. So here the temperature we are controlling, so the temperature is lower down, then the less soluble compound will be precipitated and then we are separating over here. Then the separation of this will done by centrifugation. So the centrifugation, the potash mother liquor is refrigerated and the furnished borax. So whatever the borax and KCl we are separated, so here the potash mother liquor, it will have the potash in quantity, and the furnished borax which is precipitated out, that we can separate by the centrifugation process. So if here you can see the brine which is coming and the process by which we can separate the salt. Here we can see the borax, then we can have the lithium carbonate, we can have the sulfate, and we can have the NaT or soda ash. So the brine which comes over here, so it is concentrated here in triple effect evaporators. So the brine will be concentrated over here, and then here we have the carbonate and sulfate with common salt and the lithium chlorides, and here you can see the borax which is precipitated out, that we are separating. So here the borax will come in hot solution and then it is cooled and we get the refined borax, whereas the other stream it will go and then overflow filter and wash with the lake brine. So here you can see the burkite dissolved in water and cooled and the lithium froth floated. So here you can see this stream, it will produce the lithium salt, and the other stream which is coming, which is the filtered one, which can separate to form the sodium sulfate, and we can have the soda ash. So here you can see the temperature is maintained. So temperature will have the major key on the separation of the salts. So here the major thing is solubility at various temperatures. So that is used to separate these salts. So here you can see the diagram for the various salt separation. So here you can see the brine from the lake which composed of all salts, then water is evaporated to have the concentration, then here the liquor will come. So mother liquor one, so where these salts, the potassium chloride, that will be separated, whereas in other side we can separate the borax, whereas what the liquor which is present, which is gone, which is sent out to separate the salt, which is sulfates, carbonates and the lithium salts, and whereas this liquor which is highly concentrated in NaCl, and NaCl we don't have the use as such, it is sent back to the lake. So here you can see the salts are separated. So here we are separating the potassium, here we are separating the borax, here we are separating the sulfates and carbonates and lithium salts, and the remaining liquor we are sending back to the lake. So this is a diagram for the potassium chloride and borax by Tona procedure. So we have seen already the borax we get by the cooling, and borax will be precipitated out first, and that can be separated by centrifugation, whereas the potassium chloride, that will remain in solution and that can be separated out in other things. So here we can see the raw brine which will come, the Searles Lake brine, and that we will lead the potash, then borax and the other salts. So what happens in this procedure we will see. So here you can see the evaporators, then condenser, then heaters, then MLA will represent the mother liquor, and then the vacuum crystallizer. So what happens here we will see in the description. So here the first thing we will do is the concentration and the soda product separation, then we will see the separation of potassium chloride and the separation of borax. So here the concentration and soda product separation, that will be done by the raw brine is mixed with end liquors from the borax crystallizing house and pumped into third effect of triple effect evaporators. The brine is hot concentrated and salted out in the 3 effects counter to the stream flow. and the suspended salt of the sodium chloride and the carbonate sulfate to removed from liquor of each effect by continuously circulating the hot liquor through cone settlers called salt separators or salt trap. The underflow, which is liquor most of the case, of the first effect cone passes through an orifice into second effect cone, receiving countercurrent wash with clarified liquor from second effect cone. Then salts from first and second are given wash to countercurrent from third. The salts from first, second, third receives wash with raw brine when they leave third, and all are hot washes and combine overflows, filter, filtrate, return to evaporators again. The cake, which consists of the sodium chloride and the carbonate sulfate, is sent to soda products plant, and the final hot concentrated liquor is withdrawn from the overflow of the first effect cone into clarified and then pumped to storage at the potash plant. So that was happening in the AAA apparatus. Then whenever you want to separate the potassium chloride, then the clarifiers contain saturated KCl solution, which we have seen earlier. Then KCl obtained by cooling at 38 degrees centigrade and crystallizing in 3-stage vacuum cooler crystallizers. Then water is added to replace evaporated one to avoid NaCl in KCl. So here the major problem will be the NaCl contamination. So as soon as the water which is evaporated, so we have to refill it back with the water so that NaCl will remain in the solution and KCl will only be precipitated out. So cone settlers separate KCl as suspension, and KCl then dried in rotary dryers and then stored and shipped in bags. Then separation of borax. So the potash mother liquor is cooled in vacuum crystallizers. Water evaporated is cooled and mixed to avoid KCl in borax crystals. Then borax crystallizes out as a crude sodium tetraborate and pentahydrate. The crude borax is filtered off and then washed. The filtrate is returned to the start of evaporator cycle. When necessary, the crude borax is refined by recrystallization, and this salt is centrifuge dry and packed for shipping. The lower burn process involves carbonation with flue gases from the boiler point. So when the sodium bicarbonate separated, it is calcined and converted into the dense soda ash. So we have seen earlier the process of the soda ash conversion from the sodium bicarbonate in chloralkali industry. Then crude borax is crystallized from carbonated end liquor by cooling under vacuum and filtrate it returned to the lake. So here what are the major engineering problem? Here the requisite the heat transfer when salt crystallizes out at the same time, and this was solved by the outside heaters. So instead of keeping inside, we can have the outside heaters to heat it, and the superheated solution is flashed into evaporators. So superheated, when it is flash evaporated, the water will come out as a steam and the salt we can gather, and the heat transfer is also facilitated by vacuum cooling through vaporization instead of cooling in pipes. So here if we can use the vacuum cooling, then the problem with heat transfer also can be solved in this case, and we can have the good heat transfer which is not available in cooling in pipes. Now we will see the manufacturing from sylvinite. So it was discovered by the Carlsblad in 1925. Here the NaCl was the trouble in KCl separation. So NaCl will always come as impurity in potassium chloride. So the cold mother liquor is heated to 110 degrees centigrade and then passed to steam heated turbo mixer dissolver in countercurrent manner. So KCl goes into solution with NaCl. The clay in ore gets suspended and forms colloids, and this is separated in thickener by acetylene, and the saturated overflows is fed to vacuum crystallizers. The vacuum is maintained by jet steam ejectors. So this is the unit process where we use to create the vacuum. The solution is cooled up to 27 degrees centigrade where KCl comes out of the solution, so it will precipitate out at this temperature. So it is separated and liquor is passed again to reuse. The thickened mass of potassium chloride is filtered, washed and then dried, and then it is crushed, screened and conveyed. So here the problem was NaCl with KCl, so this can be solved. So crushed and size saturated brine with NaCl and KCl is separated by difference in gravity. So the potash company of USA separates by soap flotation method. So the ore is wet grounded in ball mills to 100 mesh. The mill product is treated in 2 series flotation cells to float off NaCl and depress KCl. So the NaCl will be preferably will be floated. The NaCl then washed out and filtered, saturated in KCl is crystallized separately. So what they will do, they will have the soap flotation where the NaCl is floats out over the solution, whereas the KCl is not comes in float, or it is depressed to come in the foam, and the KCl will remain in solution. As the NaCl comes out in the foam, the KCl will be concentrated in the mother liquor, so that foam we can separate out, and the water liquor is present, it will be rich in KCl, that can be recrystallized and filtered out, and then we can wash the crystals and we can pack them for shipping. Then International Minerals and Chemical Corporation also uses the flotation technique to separate out NaCl from KCl, and it obtains the potassium sulfate by reacting the potassium chloride with a mineral langbeinite, that is potassium sulfate and magnesium sulfate. So magnesium often is used for the Mg recovery, then potassium chloride sulfate or potash magnesia production. So here you can see the solid represent the solids, then the dash line they will present the liquids, and the dash line with the dots they will represent the vapors. So here you can see the salt mixture, it is screened and then it is grounded in mesh, then it is dissolved. So here you can see when it dissolved at 110 degrees centigrade around, then it is vacuum crystallized, then it is separated out the salt and the water. The water is passed. So here the water we are passing through the softener to remove any impurities, and the soft water which is free from the hard ions, that will come here. Then KCl will be crystallized out, and that we are sending. So here the KCl rich solution that will come here, then it is settled, then with the hot air we will separate out, and whatever the salts which we are getting, that is sent to cooler, and then we can store them for the shipping. So here this is the main thing, the dissolver, because you have to take care of the NaCl salt concentration in KCl. Also the major part of this process is the crystallizers. So in the vacuum cooler crystallizers, you have to always take care that the KCl is always preferentially crystallized out, depend on the solubility, and not the other salts. Whereas the soft water is necessary to avoid the impurities which comes from the normal water. So here if you see in the requirement for 1 ton of KCl, then we require the sylvanite about 2.51 tons, then water about 170 to 200 meter cube, then steam we require around 1250 kg, then electricity consumed is 180 megajoule, and the direct labor is 4 to 5 work per hour. So the next thing we will discuss is the potash from the Saskatchewan from Canada. So here we are using the sylvanite, which is NaCl and KCl salt, and the carnallite, which is potassium chloride, magnesium chloride with hydrated. So ore is treated with brine, which leaches out the carnallite and desalines the ore, and then separates the potassium salt into fines and coarse material. The fines are deslimed by hydroseparated and treated with amine and starch, and combined with coarse salt, which are similarly treated. The both fines and coarse salts are conducted to flotation cells to separate potassium salts from the NaCl. When the ore is treated with brine, the carnallite is decomposed, dissolving the MgCl2 and KCl crystallized out. So here the MgCl2 and KCl, which is combined salt, so here it will decompose and it will eat the potassium chloride. The fresh water is added continuously to prevent saturation by MgCl2. And although some KCl dissolves, the main brine effluent carries mostly NaCl and KCl. So the sum loss with KCl, we can get the mixture of NaCl and KCl. Then NaCl we can separate out by the soap flotation technique in later stage. So it is the diagram where we can get the potassium chloride. So here we are sending the ore. So that ore will be crushed out, and then it is passed to the hydroseparator. Then then it is sent to the filter. Then with the various operation, the KCl and NaCl what we are getting, we will send over here, and it is dried up, and then it is packed for the potassium chloride. Whereas the MgCl2 liquor, that will be sent back to the original brine solution. Then the next, the potassium salt, that will discuss the potassium nitrate. So here it is used as a constituent of black powder, now used as fertilizer. Then polytechnic mixture as a heat transfer medium and heat treating steel, and in foods also. It is made by double decomposition between the sodium nitrate and the potassium chloride. So here the sodium nitrate and potassium chloride, when they are treated, then they will give the common salt, then potassium nitrate, and it is endothermic, so we have to supply heat for the reaction. It is also made by reaction with KCl with nitric acid, as the KCl with nitric acid it will yield the potassium nitrate and chlorine gas. So that can happen in CCDs, where the potassium chloride, when heated up to 100 degrees centigrade and reacted with nitric acid, it will give the potassium nitrate, also NOCl and the Cl2, where the NOCl with reaction with nitric acid gives NO2 and the chlorine gas, and then this NO2 reacted with H2 and the O2 to yield the nitric acid back. Then potassium sulfate is produced by the potassium chloride with sulfuric acid. As we have used earlier the nitric acid, here we are using the sulfuric acid to get the potassium sulfate. The other method, by reacting KCl with mineral like benite, it is the mixture of potassium sulfate and magnesium sulfate. So it is decomposed to yield the potassium sulfate as a product. Then it is preferred for these crops which include tobacco, some fruits and vegetables. The crude salt is also used occasionally in the manufacture of glass. And potassium sulfate is also used as flash reducer in artillery propellant charges, and it reduces the muzzle flash, then flare back and blast over pressure. And potassium bisulfate is readily prepared by potassium sulfate by reaction with sulfuric acid. Then it is strongly acidic material and used as a flux for ceramics. This compound is commonly used in conversion of tartarates to tartarates in wine. And potassium bisulfate is also used as a disintegrating agent in analytical chemistry. And the potassium hydroxide, which is important base, so it is made by electrolysis of KCl using procedures similar to those of sodium hydroxide manufacturing. Then it is used for the production of potassium carbonate. So potassium carbonate from sodium hydroxide we can prepare, and the liquor, fertilizers, then potassium phosphate, then potassium permanganate, pesticides and other chemicals. The potassium hydroxide is often main active ingredient in chemical cuticle removers and used in the manicure treatments. So here the manicure we can use to remove the hairs from the unwanted hairs from the skin. Then potassium carbonate, which is also named as pearl ash, is made by reacting caustic potash with carbon dioxide. Then this is a preferred source of potash for hard glass. Also used in pottery, smelt soaps, for engraving process, for finishing leather, and absorbent for the acid gases as the carbon dioxide and hydrogen sulfide from the petroleum refinery industry. Then pearl ash has been used for soaps, glass and china production. Then is also added to hard water to soften the water. So the hard ions, that is magnesium and calcium, that can be removed by adding the potassium carbonate. Then the potassium bromide, that is KBr, is the classical sedative which was used earlier, but now it is the greatest use in photographic emulsions and photo engraving. Then it is made by first forming iron bromide by the reaction of liquid bromide and the scrap iron. This main reacted with potassium carbonate, sometime with hydroxide, to form salts which is filter and crystallize. So here the iron with bromine gives the iron bromide, which is reacted with carbonates to yield the potassium bromide, which is used in photographic emulsion mainly. And the potassium iodide, it is made in essentially the same way as the potassium bromide, except the iodine is used to dissolve the iron. It is valuable for photographic use in animal than human feed. So iodized salts is mainly in iodized salt the potassium iodide will be used. So the iodine which is supplied to human being, which will prevent the thyroid malfunctions in human body and in pharmaceutical preparations. Then potassium acid tartarate, so it is pomace, the fruit residue left after pressing fruit for juice, and argos, the precipitated form in wine wats, are processed for the domestic production of potassium acid tartarate. The crude argos also imported, then leaching and crystallization produce the commercial salt. As cream of tartar, it is used in some types of baking powder in medicine and as the potassium sodium salt in the crystal for electronic use. Then permanganate, so it is the very familiar name because it is used to treat the water, and it will react with the bacteria and it will kill them. So to purify the water from the bacteria, we generally add potassium permanganates in the deep wells. So it can be made by passing carbon dioxide through a potassium permanganate solution, which is made by treating magnesium oxide with hydroxide and O2. This is a much favored laboratory agent, is as far too expensive to use as commercial oxidizing agent, and hence it is made in only small quantity and used in only laboratory reagent or the water treatment. Then the potassium dichromate, which is oxidizing agent. So it is another expensive oxidizing agent with a few specialized industrial use, which can be filled by the less expensive sodium salt. It can be made by roasting caustic potash, quicklime and chrome iron ore. So here the iron ore or the iron chromate reacted with carbonate, which will lead the potassium dichromate. Then the quicklime serves only to keep the melt porous, so air can enter and react. It can also be made by reacting the sodium chromate with the KCl. So we can refer to you for the other. The next industry we will discuss in the modules is soap and detergent and the glycerin industry.